systems now used are ICP technology, inductively coupled plasma, and for drug packaging, the thermal desorber systems, which are used very well in the area of analysis of drug packaging. Not to forget about IQ, QPQ, which are the meeting deadlines, which are all available with all these equipments. Another area which is for moisture content and composition analysis is TGA, thermal gravimetric analysis. Then by GC you can have organic modal impurities. Then by atomic absorption spectrophotometer you can find out the metal content. This is the area which is in QA/QC. We are already aware much more about the HPLC systems, which give the enhanced performance in active ingredient analysis, impurity determinations, stability studies, and dissolution analysis. Now, just to mention, this is a new technology which about infrared, which I want to just show it. It's just doing the sample as it is without any preparation. I'm just showing one sample for one technology. You can see over here, there is an instrument where you can keep your tablet as it is without any preparation. Suppose even you want to know the spurious drugs, counterfeit investigations. I was hearing this in IPC, people were talking about counterfeit investigation. This is the area where you can put your tablet as it is. And just to show it next, you can see the tablet spectra in one go, and the right side where the spectra which is taken, what is shown in green is how much pressure you are applying it on a tablet, which will be consistently given. So you can able to find out with the technology which compound or which material it is there in presence of excipients itself. So you are not doing it. So this is just one of the examples which I am showing. Another classic example which I want to mention here, because which is like a growing field, because somebody mentioned in the morning about Viagra tablet, because I was in UK last year when this technology was introduced, where they were studying about Viagra tablet for content uniformity. When we talk about tablet, we do it content uniformity by maybe use your dissolution, or we do it by using it by HPLC. But as soon as you dissolve it, you are losing it, that where is the content uniformity. So where are the active ingredients on a tablet, or when you want to look for. So it's a technology which is infrared microscope combined with the FTIR system. And to the left side of it you can see the morphology on the screen. By seeing the morphology you can click it just to show one of the examples. I'm taking a Tristan cold relief tablet, where you can map it on the, you can have the morphology on the screen. The aim over here for microscope to enhance the image, but it's not enhancing as we are doing it in electron microscope. But the idea, basic concept is to take this spectra or to identify the compounds. So you can have mapping of the tablet on the screen or in suspension. Certain particles are there in suspension, and if you want to do that, you can see over here. At the right side, which you can see, there are 3 marks which have been done on a tablet with different colors which you can see. And if you want to scan on that, with a single scan, you can see that it is caffeine, it is aspirin, and it is moisture. So it's a dry scan tablet which is done by 40 micron wing area. So this is some of the examples which have been done for this sort of work, some of the work which we are doing it at our technical center in Mumbai, where we have got 4 technologies right now available. For last 1 year we are working, and fortunately, okay, maybe as a we have got the people who are from pharma, so some of the work is already done in pharma, but basic idea is to show what sort of work can be done. So this is few examples I have shown it, and if anybody is interested to know more about it, I'll be happy to tell it or send it. Thank you.
You can take 1 or 2 questions. Status is the chairman of Messrs. Chemical Equipments Private Limited, Mumbai. He is also proprietor of Pharma Engineers, Mumbai, Messrs. SF Engineers and Consultants, Mumbai, and he is also director of Pharma Technologies Private Limited, Mumbai. He has experience of over 30 years, and the nature of work which he does, or like has experience is R&D, process engineering design, plant and equipment design, manufacture of chemical and pharmaceutical process equipment. Well, the subject he has chosen to speak to you today, multi-purpose reaction cum distillation unit. As I understand, that's a very, very important equipment for the drug industry, because everyone is looking for multi-purpose reactors and distillation units to cut down the cost of investments in any drug industry. So it's a very, very important aspect of the drug manufacturing. And I would, without taking too much time, request Mr. Sunil Markishna to deliver his talk. Thank you.
The organizers of this seminar, Dr. Khanna and distinguished delegates. First of all, I wish you all a very happy new year, and thank you all for sparing your valuable time and giving me this opportunity to tell you about the work we are doing at Chemac Equipment Mumbai. The theme of this symposium is A Peep in the Future. We are looking at the challenges and opportunities which the next decade is about to offer us. I personally take this as a source of inspiration to do deep thinking and come out with the technological breakthroughs which will bring our industry and our country to the forefront of technological advancement. I know that we have very highly educated scientists, chemists and engineers in our industry and research institutions who possess very sound knowledge of their subject. They also have brilliant ideas, but the ideas sometimes die out as they have no means of implementing them into practice. We at Chemac Equipment are always looking out for opportunities to assist the research scientists. Ever since this idea of speaking about our R&D model pilot plant was given to us by Mr. Brahma of Pharma Business and Technology, we have been thinking of offering a unique product to all the R&D laboratories which will facilitate top-grade research activity. Realizing the difficulties faced by R&D chemists in obtaining all the data required for scale-up and design of plant equipment from the lab experiments which are usually conducted in glass apparatus, we decided to design and construct a model assembly which will facilitate delivering all the relevant data easily. It is often cumbersome for a chemist to arrange a glass assembly in the lab to start his work. Also, he has limited choice of selecting various types of stirrers for handling different consistencies of reaction mixtures. The glass assemblies prohibit working under a wide range of temperature variants. It is also difficult to get cylindrical shape of glass reactors which may represent the shape of normal SS reactor in a chemical plant. Quick heating and cooling is often difficult unless the heating mantle is first removed and a cooling bath is arranged under the reaction flask and vice versa. The glass assemblies have to be very carefully arranged and well clamped before any work is started. They cannot hold pressure. It is also impossible to distill anything under high vacuum, say 0.5 torr, under stirred condition in a small glass assembly. Except for providing visual aid, the glass assembly does not provide any special advantage unless, of course, a corrosive reagent, which cannot be handled in a stainless steel reactor, is used for reaction. Moreover, a chemist cannot get an idea of the amount of energy required to conduct the reaction or distillation from a glass assembly. He can get the data regarding the material balances, but it is very difficult for him to judge the energy requirements while working with laboratory glass assemblies. In short, except for the reagent, nothing is the same when the experiment is done in the lab in glass and the same reaction is done on production level in stainless steel reactors. Chemists and chemical engineers often spend a lot of their time standardizing the processes in the plant. Most often, a lot of changes in the process parameters are required to be made before a batch process is standardized in the plant. Sometimes the economic calculations go haywire and the process, which looked very attractive in the lab, has to be declared as practically not viable. After taking into consideration all the possible difficulties that usually scientists come across during their research work, we have come out with a versatile reaction cum distillation assembly to overcome these difficulties. Please show this. We are sure this unit will provide all the working facilities to the research chemists and engineers and shall help them take a leap into the new millennium with technological advancement. First of all, I will describe this unit to you. The R&D pilot plant unit which we have designed has the following features. See, this is the main reactor or the SS cylindrical reaction unit provided with the SS jacket to circulate cold or hot medium through it. In addition to this, a suspended SS coil is provided to the vessel to circulate hot oil through it whenever the contents are to be heated above 140 degrees centigrade. You can see the coil there which is suspended into the reaction vessel. The vessel has a top and the bottom spherical dish which truly represent the shape of the regular reactor in the plant. In case of glass apparatus, we often have only spherical shapes and we do not have cylindrical shapes. So we have the difficulties in scaling up. The bottom dish is welded to all the shell, whereas the top dish is joined through the flank. The vessel has an adjustable variable speed steering having a turbine anchor driven by a 3-phase frame hook motor attached to a gearbox. This is the steering system which you can see with the belt and pulley drive, wherein we can change the revolutions per minute of the stirrer by selecting the proper ratio. The drive provided is a belt and pulley type. The stirrer lantern assembly comprises the bearing housing and an externally cooled mechanical seal. The entire steering assembly is thoroughly aligned and is mounted on the top dish on a cold pad. You can see that there is a cold pad here. Often the mechanical seals cannot be installed on the top dish directly because the seals do not work out well, they give in at higher temperatures. The mechanical seal is provided with a thermosiphon to keep it cool. There is a thermosiphon provided here which keeps the mechanical seal always cool. Thus the life of the mechanical seal is extended. The top dish is provided with a light and the side glass to facilitate viewing of the reaction in the vessel. We also have a side and light glass here which will facilitate viewing of what is happening inside the vessel. An arrangement to quickly detach or attach the vessel to the top flange is provided to facilitate the replacement of turbine or anchor as and when desired. Now many times we need to change the pattern of the steering, and sometimes we have to have an anchor to negotiate with some slides, and sometimes we have to have a turbine stirrer to sort of stir properly the binary systems. So we need to change them very often, and so therefore we are giving a system wherein this vessel can be lowered down on by means of a jack or by means of a trolley, and the same can be attached again after replacing the stirrer. The following additional attachments are provided to the vessel. There is a thermo well there, wherein we can insert a sensor for the thermometer, and a digital display thermometer is being provided there. A pressure gauge dial type with an isolating valve, a safety relief valve in SS316, charging nozzle with an isolating valve. A glass visor is provided between the dosing tank and the reactor to see and adjust the rate of addition manually. See, there is a glass visor here which is provided to see at what rate we are adding a reactant inside there. An extra nozzle on the top dish to facilitate addition of solids. There is an extra nozzle here from wherein we can add the solids inside the reactor. A vapor nozzle with an isolating valve is provided to facilitate conducting hydrogenations or oxidations in the same reactor. Now there is a valve here which can be noticed, which is provided to isolate the rest of this total assembly from the main reactor. Now this is being done because you see sometimes if one wants to conduct hydrogenations or oxidations in this reaction assembly, then the hydrogen will also go up and occupy the entire balance of the accessories here, and that's quite dangerous. So we would like to confine the hydrogen gas to only the reaction vessel and reaction vessel here, and it should not be allowed to go up into the column section there. So that is how we have provided an isolating valve there. A gas purger with an isolating valve is provided to facilitate introducing a gas like hydrogen or nitrogen under pressure. There is a gas purger here which is provided so that we can pass the nitrogen or oxygen or nitrogen or hydrogen, whatever be the gas. A bottom outlet with a glass feature is provided to facilitate withdrawal of the contents from the vessel. There is a small bottom glass feature provided here at the bottom, which will facilitate viewing and separation of the phases from the reactor. A side outlet is provided to take out samples from the reaction mixture while the reaction is being conducted. You can see a small side outlet here, which is provided to take out the samples and study the samples while the reaction is still being conducted. The vessel is designed to take up pressures up to 500 psig and is capable of working under full vacuum. We have designed the vessel in such a manner that we can take pressures as well as the entire assembly can be worked out under high vacuum. A dosing tank of 5 liter capacity in SS316 with charging line, vent vacuum connections at the top and the discharge nozzle at the bottom. This is the dosing tank which has been provided here, from where one can charge one of the reactants slowly or dump it inside the reactor. This tank is also provided with a sight and light glass to see the level of the liquid in it. It is mounted at a suitable height above the main reaction vessel such that the contents of the tank can be emptied by gravity into the reactor. This is of course by gravity field that we are showing it here, but we can have a dosing pump also. Vapor head with the isolating valve and glass visor. We can have this is the vapor head which is being shown here. There's a vapor head there with the glass visor there. Now this vapor head, what it does is actually it does give you the facility to separate any water of reaction or two phases that may come out from the reactor while the distillation is going on. Say for instance, if you are doing any esterification, then you would like to remove the water of reaction from that. And that glass visor gives you that facility to separate. A primary reflux condenser or a heat exchanger with a facility to heat or cool. On the top of that vapor head is a primary reflux condenser or a heat exchanger, as we may view it. And this is the one which is provided in between the column and the main reactor, because sometimes you would like to use this assembly as a short head, short distillation unit, and or maybe sometimes just a reflux condenser. A packed column section providing at least 8 to 10 theoretical stages to accomplish good fractionation. We have a column section packing there with a structured packing in that, wherein it would provide about 8 to 10 theoretical stages for separations of liquids to take place there. A reflux distributor with a pneumatically controlled valve to adjust the desirable reflux ratio. And on the top of this column we have a reflux distributor with a reflux control valve there, which is pneumatically operated, so that we can adjust the reflux ratio into this column. Secondary condenser of adequate capacity to condense all the vapors emerging from the column. Now at the top of the column there is another condenser, which is the secondary condenser, which is of adequate capacity, which takes care of all the vapors which will be coming into it. A glass visor through which the approximate rate at which the distillation is being done can be judged. Now below this reflux distributor there is a small glass visor from where one can judge at what rate we are distilling out the material from the assembly. Vapor trap vent, which indicates whether the condenser is performing well or not. Now we have a special venting system here, which is also externally cooled. Now this is to, if supposing that condenser, water is not circulating inside that, or some kind of airlock is there in that, then one would not know at that height whether the condenser is performing well or not, or the boiler rate is higher than the condensing capacity. Then the vapors are likely to come out from the condenser. So this vapor trap from vent gives you that idea. If the condensate drops, it comes drop by drop, you can see from that bottom meter there, if the condensate is coming out from there, and you can know that the boiler rate is much higher than the condensing rate. Subcooler, which accomplishes subcooling of the distillate. Below this vapor head, we have a subcooler here, which subcools the hot material which is coming out as condensate. A primary receiver to collect the distillate is below that subcooler, and a secondary receiver to collect and withdraw the distillate is below that. In addition to the features stated above, the following utilities and services are provided to the assembly. On one frame, steel frame, we also provide the following utilities and services to this assembly. A flame-proof electrically heated hot oil system with a heat exchanger to facilitate cooling of the oil when required. An oil circulation pump is provided to attain forced circulation of hot or cold oil through the jacket or inner coil of the reactor. Then we also have an insulated water tank with a water circulation pump to circulate water through the condenser, subcooler, heat exchangers and the traps. Both the above units are provided with thermometer to observe the temperatures. We can also provide oil-sealed double-stage vacuum pump, which is being shown there with a trap there, to evacuate the assembly and facilitate distillation of any material under high vacuum. Then we also have an optional utility which we can provide on request, and that is a small chilling unit with a brine reservoir and brine circulation pump to facilitate conducting reactions below room temperatures up to -10 degrees centigrade. An electrically heated steam generating unit can also be provided up to about generating about steam about up to about 100 psig, and it can be used and it can be attached to this system. All the hot and cold surfaces are well insulated to avoid heat losses. The entire unit is provided with a flame-proof control panel, which has all the control switches and digital thermometer display units fixed in it. An energy meter is also provided to know the total energy consumed during the entire batch. Now this is very important. Some of the other important aspects of this assembly are that the entire assembly is constructed in SS316 except for the pumps and the hot oil system. All valves and pipelines coming in contact with reaction ingredients and the product are in SS316 and can stand pressures of 500 psig or full vacuum. The entire assembly has tongue and groove type flange joints with PTFE gaskets between them. All the parts of assembly are buffed, polished and painted to give an aesthetic look to it. The entire reaction assembly, utilities and services are mounted on a single frame. The types of reactions which can be conducted in this assembly are, can you give that second transparency? And there are esterifications, condensations, polymerizations. We can make ethers in that, hydrogenations, oxidations and reductions, high temperature reactions under close conditions, nitrations, sulfonations, fusion reactions, cyclizations and isomerization. Any other liquid phase reaction, homogeneous or heterogeneous, which can be conducted in this SS316 reaction assembly. We can take all sorts of reactions in this. Can you switch over to the first aspect? Because I was to go into the details of reaction. Anyway, I think I can explain it if somebody asks. I am sure that such a unit, as described above, will be an asset in all research laboratories, as it will give all necessary data to the research scientists regarding material balance, energy balance, and all the necessary design data for scale-up. Above all, it will bridge the gap between the thinking of a chemical engineer and a research chemist. For further details, please contact me anytime at Chem&A. I once again thank you all for giving me this opportunity to speak about this new and unique assembly, which will be available within a month from now. Thank you very much.
Any questions? One or two questions we can take before.
I was only wanting to know the price.
Yeah, order of magnitude will be around 10 lakhs.
What size?
This will be about 50 liters.
Well, I just make few comments that it's very important unit. I think the bulk drug and fine chemical industry will know that most of the units which were available in India, they leak and they cannot retain the vacuum for a long time. And we had a lot of problems in our own bulk drugs manufacturing. Then finally we imported the unit sometime in late 80s when we started NETD in India. So So at that time I still remember that it's so important. I mentioned some of the units which are used in the lab scale. Buki is a name actually worldwide famous. Still everyone uses in research. And there is no replacement for Buki. Still, that was launched I think 50, 30 years ago. But still Buki is Buki, which is a vacuum distillation at a reduced pressure and reduced temperature. And I think you should expand your business toward the smaller scale units, which will help R&D to available on within India. I think I wish you all the luck. Thank you. I would like to thank you on behalf of Pharma Business Mobility for your excellence.
Thank you very much.
Thank you. May I request Dr. Khanna? We will have one more session before we break for tea. And may I request Mr. Hegde to come on to the stage now. Mr. Hegde is BSc Chemistry and Botany, B.Pharm, M.Pharm, and he's of course a postgraduate diploma in Operational Management from Bajaj, Diploma in Management Studies, and he has worked for 34 years in the pharmaceutical industry. Various activities which started with product development, manufacturing, packaging, plant management, and distillation, and a whole lot. And he's also worked for a lot of companies which include Pfizer, Warner Hindustan, DCGA Pharma, Park Davis, Ranbaxy, Pex, and Colgate. He was the Vice President of Operations in Max India, New Delhi in 1990 to 1993. And he is now the Managing Director of Astra Idea in Bangalore. He's been very active professionally. He's a life member of Indian Pharmaceutical Association, Joint Secretary of IPC Health in Delhi, Executive Committee member of the Organization of Pharmaceutical India, and of IDMA. And he is, of course, member of the editorial board of Pharma Manager, member of the National Executive Council of Chemtech, member of Executive Committee of Industry Pharmacy Association, and so on and so forth. So he's an examiner too. Mr. Hegde looks is very, very humble and unassuming person. He's a very fine gentleman and a great achiever. We have seen Astra Ideal at what places after he took over. Welcome to you, Mr. Hegde. And may I request our next speaker, Mr. Gurmani, to come over to dais. Mr. Hegde, will you?
Good afternoon, everybody. It has been very kind of Mr. Devinder Pal, who I often say has been one of the very few mentors who has made me what I am today. And that's why you heard a lot of things. To what extent I deserve, I do not know. But anyway, Mr. Pal thought always that I could do better than what I was able to. And hence, perhaps he has called me when there are better scientists and technologists and innovators who have been chairing this session. Well, I have the pleasure to introduce our friend, Mr. Ram Gulwadi, whom I met only today. Unfortunately, last 4 years, a little over 4 years, I've been away in Bangalore. I've not been able to attend too many sessions in Bombay, and that's one of the reasons why I couldn't meet him earlier. But that doesn't mean anything. Mr. Ram Gulwadi, I understand there is B.Pharm Honours from the famous Birla Institute of Science and Technology at Pilani in the year 1979. After a brief stint in marketing with Raptor Process and Drugs, here is a gentleman who went into the pharmaceutical R&D and has spent most of his career spanning over 15 years in this field. Rarely a marketing guy comes into R&D in technology. Usually, the technology guys, unfortunately, enter areas other than technology, and that has been the bane of many of our Indian industries. And here is a person who has gone into the other fold, and that's a welcome thing. And I feel more non-technology guys get into technology so that technology gets more recognition, not merely by the technologists, but by people who are seeing the technology from the other side. And as Dr. Khanna rightly said, there is a need that technologists innovators, scientists must be not on par with business and political people, but they must be above business and political people. There's only a correction, Dr. Khanna, because I value R&D people and the technologists and innovators like Madhuri's son, who have made this country proud. So, coming back to Mr. Gulwani, he has had a long 8 years period in CIPLA, one of the most famous organizations that this country has. For the last 7 years, he has been in this field of pharmaceutical excipients, like coating materials, development of specialized equipment in fluid bed processes, and his more recent activities include marketing of biotechnological specialties and pharmaceutical consultancy services in North Africa, Middle East, and the Far East. Mr. Gulwani is happily married, and fortunately he has just one wife and 2 children. And that's what I think even the Madhya Pradesh Chief Minister wants to have people in government with only 2 children while he has 5, I believe. So it's a good direction, and I think well thought of. So I think he complies and conforms with those norms. But my knowledge of whatever pelletization technology has been learned from our friend Bodhi Raja, I think, who taught quite a few of us more than what we were taught in schools or colleges. So, but then this technology has undergone tremendous changes in the last 40 years, and some part of which I think Mr. Madhuri gave in his, I think, elucidation. And I think we are going to have one more fine session from Gulwani, and before time runs out and Mr. Devendra Pal shows me the way, let me give the way to Mr. Gulwani. Thank you.
Mr. Devendra Pal, ladies and gentlemen, it gives me great pleasure to appear here in front of all of you and to be able to present some of my thoughts on pelletization technology as I have seen it develop over nearly the 2 decades that I have been here. For some of you, I may have nothing really new to tell, but for the rest of you, maybe yes. Nevertheless, I hope that what I intend to present here for the next 15 minutes or so that I have been allotted certainly interests you one and all. I also intend to keep this presentation on a light level as far as the technical details are concerned and bring home the advantages that technological advances have brought into pellet manufacture in recent years. Various industries have routinely utilized pelletization processes since the beginning of this century, or should I say last century. It was really the need for producing sustained release products that brought about renewed interest in this technology somewhere in the mid-50s. The advantages of pelletization, especially for delayed action, for over 10 to 12 hours or more, was the main reason for increased formulator interest in this technology, which in turn resulted in their adapting advances made in the confectionery and other industries into this field. Thus came upon the now popularly carried out conventional coating pan method, utilizing sugar seeds to produce pharmaceutical pellets. But soon, the limitations of such technology were brought to fore. With the advent of fluid bed process technology, there came about a quantum jump in the way pellet and fine particle coating could be carried out. Particularly over the last 2 decades or so, this technology has grown to be accepted worldwide and is now almost a routinely carried out process in many parts of the world. We shall now look at briefly the past practices, recent advances in the area of pelletization technology. The advantages of pellet-based dosage forms over other systems are the ability to control dust generation, thereby avoiding contamination and offering operator safety, the ability to achieve separation of incompatible ingredients, to improve stability, densification of drugs which otherwise would be difficult. And a classic example is ibuprofen to the extent of 800 milligrams in pelletization. The ability to virtually develop any drug in slow release format, the ability to combine pellets of different release patterns to achieve the right profile in one single capsule, and the ability to achieve excellent taste masking. The ability to distribute freely throughout the GI tract, maximizing absorption, reducing plasma fluctuations, and thereby lowering side effects without affecting bioavailability. Variations of gastric emptying rates have little effect on the overall bioavailability as opposed to depot-based dosage forms. Then of course the advantages of having a multi-unit format as opposed to a single unit depot-based system itself builds a greater safety margin that virtually negates the possibility of drug flooding. Now let's go on to the techniques of pelletization. Since the mid-50s, pelletization involving sugar beets as base materials for drug loading in conventional pan has remained the mainstay until more recently. Then you also had the compaction and the boiling process, the sterilization and extrusion process, and of course more recently the use of fluid bed process technology. I think we have already covered this, so we'll go to the next slide. If you look at the last, in the last few decades, most of these methods were primarily skill-based, and they were highly limited, they were time-consuming, often with low yields, difficult to validate, and inconsistent results. If you see the pelletization process as it has evolved, on the one side you see the compaction, which is the extrusion and sterilization process, and on the other side you had the layering, which was derived from the confectionery thing on non-covalent sugar seeds. This is the powder dusting and then the solution and suspension layering. The coating pan method we have seen is, for the last 3 to 4 decades is there, but a very high level of skill is needed to do this consistently and rightly. It's very difficult to validate. Reproducibility is often a tough ask. Wastage due to losses, there is loss in the exhaust, there is loss by sticking to the coating pan, etc. Then of course the process timing is very lengthy. Agglomeration is a problem that is not always easy to solve with these systems. Then came the monomerization technique, which was originally, I suspect, developed or adapted from the pesticide field, where they wanted something to achieve quick dust control. Now, when monomerization was adapted into pharmaceutical technology, initially it was found that it's a very fast method to obtain spheres from moistened powders. But then they also found out that it's not a very robust process. By that, what I mean is the acceptability of materials to produce very spherical spheres is very low. That's why it's highly limited. Then it's a multi-lot process rather than a single batch process. And often it requires other equipment to continue on and complete the process. Then came the air suspension coating or the fluidized bed technology. Now this involves suspending powders, granules, tablets, pellets against a ballast of treated air stream in suitably modified fluid bed columns. Fluid bed technology has revolutionized pharma industry's capability in handling of powders and particle coating. From mere drying of granules in the early 60s, the advantages of fluidization as applied to coating and drying operations gave rise to a host of possibilities in the area of coating of small particles. Thus, fluid bed technology, which primarily uses air suspension coating, became increasingly popular, first in Europe and then in other parts of the world. The advantages made in this technology over the last 3 decades have led to the evolvement of 3 basic types of process mode within the fluidized bed mainframes. They are the top spray particle coater granulator, as we understand now, the bottom spray, or specifically referred as the booster coater, and then of course the latest version of that, which is the Canister spray roto granulator. The top spray granulator or coater is perhaps the first of the variations of the fluidized bed mainframe. This developed with the just introduction of a spray nozzle into the expansion chamber of the fluid bed dryer. This is ideal for spray granulation and for hot melt applications. This was used earlier for pellet coating before the advent of booster coating. And this mode is of course very useful in particle coating as well. Now we look at the bottom spray. This is the main product chamber we are seeing, and then the booster chamber. And you see there the arrows indicating the movement of pellets within the booster and outside the booster. The idea is to maximize the population of pellets within the booster chamber, so thereby you can increase the spray rate and achieve much faster, much shortened process timing. This is ideal for pellet coating using solution layering, excellent coating uniformity due to the organized movements of particles inside the booster cylinder. The nozzle inaccessibility during coating is considered an undesirable facet of this kind of spray mode. And then of course, of late, higher spray rates are possible with certain improved designs in the booster chamber and the spray nozzle. Then we have the rotogranulator version. There you see there is a central disc which rotates at predetermined speeds, and then the spray is tangentially introduced into the rotating pellets. Now, I have shown a pellet on the left side. This is subjected to three forces. One is the fluidizing air force, the blue upwards arrow, and then the centrifugal force, which is shown on the tangential side, and then of course the force of gravity. Now, due to these three forces which are acting on the pellets are often found to move in a rope-like fashion. So therefore, the pellet turnover rate against the spray nozzle and the spraying junctions are quite fast. Thereby, the spray rates are very, very high, and the drying rate is very high. It has a spin drying effect. Next slide, please. About this evaluation of the fluid bed process mainframe, this is an excellent option for purposes of pellet generation and even coating. Very rapid spray rates possible due to the centrifugal pellet motion, also creating spin drying effects, drug loading by suspension, and solid powder mix is possible. Critical parameters in this case include disc speeds, spray and dusting rates, besides the ratio of particle size of the drug to that of the seed material. Well, if you now let's do a fast summary comparison between the older methods and the current trends. You see that in the older methods, that's a conventional coating plan method and a monomerization method. You saw that a high level of skill is required. It's highly limited. There are often low yields. It's very tough to reproduce, and of course, inconsistency. Whereas in the fluid bed process, the newer trends, you see they are closed systems. They are fully automated. They are very low level of skill is required. They are fully validatable. And often the scale-up is fairly straightforward if you have done your homework in the bench level R&D properly. And then of course there is a very high potential. More variations have been seen in this fluid bed equipment as well. Now you have latest versions like the rotoprocessors, spiraflows, and assisted spheronizers. Now these are being increasingly introduced world over. The advantages being that you don't even have change parts. Like you don't have to change from top spray to a bottom spray, take the product out, then put your change part, then again load your product in. This is a sort of a built-in all. It has a disc, it has fluidization, it has tangential spray, it has the bottom spray and everything. And only without removing the product from the processor, one can shift from one spray mode to another. Well, our discussion will be incomplete without a small discussion on the evaluation parameters of the process pellets. Uniformity of drug loading. Now, these are some of the evaluation parameters which are critical. You have to establish uniformity of drug loading. You have to establish uniformity of dissolution profile, moisture content, drug assay and impurity profiles. More importantly, sieve analysis data, microscopic examination. Now, this is something which can never ever be understated because you are not really seeing the coating uniformity. You can't see with naked eye on smaller particles. So therefore, microscopic technique is a very essential tool in this case. Keeping quality of applied coatings and dosage forms as such. Electron microscopy, coating texture and quality, bulk density estimations, pellet size distribution patterns, particle size of drug versus release profiles, effect of pellet as well as seed material friability profiles. Now this is very, very important too. Behavior as bulk coated pellets prior to encapsulation and afterwards. Whether they cling together, whether they become a bunch of grapes. This is something which has to come out in stability studies. In final recap, we see that in comparison to the conventional coating plant techniques, fluid bed technology provides a very useful and innovative alternative to pellet manufacturing as well as other fine particle coating. Aqueous and very intricate coatings can be performed easily. And a very important summarization here is simply to state that it is automation in and skill out. Benefits, of course, far outweigh the seemingly high capital investment to begin with. Very rapid spray rates and reduced process times, unthinkable using coating plant methods are possible. Excellent sphericity control as opposed to monomerization methods. Drug loading up to 800 to 1000% can be performed routinely and over a short period of time. And of course, consistent results can be obtained. The scale of the stream is simply very fair and straightforward. And before I finish my discussion, I would like to show you photographs of some of the machines with which I will be working with top spray in position and side spray, top spray, side chamber is on the hinge. This is the bottom spray booster 6-inch column. Next slide, please. This is the customer services laboratory where I conduct trials for the customers. We develop product together, we put it through stability studies, and then we do scale-ups, and then we go the whole rock together. This is a roto granulator, and the person is loading the seed material for nitrate. Next slide, please. This is the all-in-one version, the laboratory model, with the roto granulator tangential insert in place, and then you see both the expansion chambers. The right one is called the booster bottom spray, and the left one is called the top spray. Next slide, please. This is again the bottom spray on the side and the top spray in position. The next slide, please. This is a shot taken while coating is on. This is a roto process granulation, enteric coating of diclofenac sodium is in place with tangential spray. You can see the pellets rotating on the rotating disc. The next slide, please. This is the bottom top shot of the bottom product container in a booster chamber. You can see the air distribution plate, the booster chamber, and the bottom nozzle in place. The next slide, please. This is again a small laboratory machine which is provided with only the bottom spray. It is not designed for top spray or tangential. The next slide, please. This is a 60 kg commercial model which is in place in a company in Hyderabad, and this is the bottom spray 60 kg, which is the 18-inch booster column. This is a total height of about 18 feet. With that, let me thank you all for hearing me out patiently, and if there are any questions, they are welcome.
In fact, he has finished in less than 15 minutes, and he has helped us in terms of completing the schedule. And Mr. Paul told Chaiwala that 4 baje to chai ready hona chahiye. So I think we are sure that all of you may not be at fault. Maybe in the next 3 to 5 minutes we'll have your tea. He has presented very well. I think ABC analysis, accuracy, brevity, clarity, with pictorial presentation. That's what he has given you, and it has been very simple and it has been good. And I think most of us who have not had full exposure have definitely enjoyed his short but very sweet talk, and I think we would be richer. And if there are still a couple of questions, maybe I'll grant a couple of questions with the permission of the part.
Yeah, Mike.
How much do you expect a time difference if you have a booster type of a coater and rotogranulator for a same size of a batch?
If you want a comparison, okay? If you want a comparison of the timing between a bottom spray and a roto processor, your thumb rule should be, it's going to be about 3 times shorter. If you can do a processing booster column in about an hour time, you would expect to complete in about 20 minutes. So that's rough estimation. Weight gains apart, your how long your coating process is there. But if you're comparing apple to apple, it should be about 20 minutes. Where it was in the earlier research, it's about an hour.
By saying it as a rotogranulator, can granulation also be done on this?
It need not be done actually. It could be done, but it's a very sort of a, there are simpler methods to produce granulation. When you are looking at granulation, if you're looking at spherical granules, yes, you have to use this. But if you're looking at granulation, you could just do it by a rapid mixer, granulator, diagonal type of mixers, or whatever. But here you're looking specifically for a uniform spherical size of pelletization. Pellets, if you want to make pellets, then this is what we have. The granulator word, personally I feel that it's just come out of the English language that, okay, it's called a pelletizer, it's called a granulator.
Only for pelletizing, not exactly for granulation.
Yeah.
Okay, and can drug pellets be directly made on it, like omeprazole?
can it be directly made out from the drug dough, can be converted into pellets in this processor?
The answer, you want it from me straight, is yes and no. Yes, if you have, it depends on what kind of raw material, the inherent property that you choose. Like if you have granular material in the size range of 40 to 60 mesh of a drug powder, and the rest of it if you have amorphous, then you could use it as a starting material and layer on it comfortably. The problem is, not always you get both the best of both worlds, You either get an amorphous material or you get a crystalline material. So that's why you need to start with a seed crystal like 40 to 60 mesh sugar powder or something. I will give another example. There have been trials with erythromycin base to start this without using a seed material, and it has been fairly successful. But then you need to have two different types of raw material when you start with. That is what one has to attend. You use whatever it's possible, but you have to use a crystalline starting base on which you can build something. You can't build a bigger pellet powder or something soft.
Okay, significantly which is advantageous, a booster technique one or a processor one, tangential processor one? If I have to recommend between these two to somebody, which is an advantageous one?
Just go ahead and recommend the roto processor.
Straight.
That's my personal favorite.
Thank you.
But there is one catch there. You can do everything in a roto processor, but there are certain things you can't do. You can't do in a roto processor. That one has to go. Like particle coating, you can't do in a roto processor. So you'll have to stick to a booster. But if you're talking of pellets, roto processor, you just close your eyes and go ahead. With one limitation there, that the sizes are not often as big. So you'll have to contend with a lot process. Like you take 60 kg every 1 hour, then you put it in an octagonal grinder at the end of the day and get a bigger batch. Whereas in a booster you could go up to 600 kg one unit.
Thank you very much.
I think, ladies and gentlemen, the very fact that Ram Dulwadi has evoked so much spontaneous response from all of you, I think you'll have more questions to ask, and you can definitely use the tea time to optimal use. And I'm sure Ram will help in that. Thank you very much, Ram, for having done an excellent job. And let's all use the
This is deliberate. I didn't forget. I know.
It's a visual admiration inside.
May I know? We will break for tea. Assemble 15 minutes later. On indigenous energy saving solutions for pharma air conditioning. Our next session is on indigenous energy saving solutions for pharma air conditioning, and the chairman of this session is Mr. Gopal Nair. I'm sure everybody knows here Mr. Gopal Nair, but for good order's sake, I will still introduce him to you. He is the technical director of Glaxo, which is the largest pharmaceutical company operating in India, as we all know. And as I was saying in the morning, it's the only company in the domestic market which has maintained a leading position. All the companies have gone topsy-turvy up and down. But Glaxo is the only one which has maintained the #1 position, despite all these years and turbulence. He's a graduate from Bombay University in chemistry, and he went to UK for further studies, obtained his MSc and AR-ICT from London University. He started his work with Sandoz, Wonder, UK, while he was still in the university, and he joined Glaxo in UK. And then he transferred to India in 1970. He worked in foods in Aligarh, bulk drug plant in Thana, and formulation plant in Nashik. And after getting all that overall experience, he became the boss of all of them. And not only all of them, but including all the activity which is associated with that, the support activities and services which are there. He is currently heading a very important assignment in Glaxo, what is about his regular assignment and job, and that is what they call as the power of one, where the objective is basically to link all the manufacturing units into one global supply chain. The Glaxo is looking at India as a potential sourcing country and sourcing base, and in that area, I think Gopal is playing a very important role. And I think we can all feel very proud about it and hope that it would ultimately obviously would benefit India if things are exported out of India. He's married and he has 2 children, both are settled abroad. And Gopal is a fine speaker. I've always enjoyed listening to him, but today he's doing the chairman's job. But he will still promise to tell me a couple of jokes nevertheless. Thank you, Gopal.
Invite the speaker, Mr. Surendra Shah, to come up here on the dais, please. I can see from the audience that neither cocktails and dinner nor air conditioning is all that important. We've had a thinning of the audience, but nevertheless, since it's comfortably air conditioned, we'll carry on. No jokes, Surendra. What you're going to see from Mr. Surendra Shah is a peep into the future on how to save energy for pharma air conditioning using indigenous solutions. Let me tell you quickly about Mr. Surendra Shah. He's got a degree in mechanical engineering from Clemson University, USA, and he returned from that. He's very much a hands-on person. Although he started work for Blue Star and other air conditioning companies, engineering companies, he was not very happy. He found that he was getting higher up and sitting behind a bigger and bigger desk, and he was losing his touch with engineering. So he quit all that and started his own company. And since then, he's been with this company, Pan Asia, and he's developed a lot of products on energy saving, which he will talk about. He's developed many innovative energy-saving products, 6 of which have been actually patented. The pharmaceutical industry has been using many of his products, and his R&D work is still continuing. But he confesses that his main passion, which you will hear him talking about, is natural cooling. So if after hearing his talk you decide that the best location to set up pharmaceutical company is in the Himalayas, I won't blame you. So, now, I can tell you that when you talk about peak in the future, I can tell you about the past solution for energy saving in air conditioning. Indigenous solution, and that is turning off the AC. But I'm sure Surendra Shah is not going to talk about such solutions. The next thing you must ask is pharma air conditioning any different from any other air conditioning? And yes, there are lots of differences. Yes, the answer is definitely a yes. Because if you look at office air conditioning or warehouse air conditioning or even air conditioning electron chip manufacturing unit, I think pharma air conditioning certainly poses a lot of problems, particularly if you go into the realms of sterile processing and vaccine processing, where you have to protect the product from the operator. You've got to sometimes protect the operator from the product. And so you've got to have pressure differentials, you've got to have humidity controls. So it becomes very, very important to design your air conditioning systems properly, your HVAC systems properly. And today when you look at current GMP, which requires you to keep this on for 24 hours, your energy bills are going to be very high. So any savings in energy is certainly a very, very welcome aspect to learn and understand. Air conditioning itself can be achieved without electrical energy. I mean, I can tell you an example of ours. We looked at, we decided to go in for vapor absorption system, and we found that there will be tremendous savings in electrical usage because, and we worked out something like 11 lakhs per month saving in our Worldly air conditioning, offices and everything is air conditioning. But this year, I mean, in 2000, we suddenly find that the high-speed diesel price has gone up from 6.8 rupees a litre to something like 12.37 rupees a litre, and throwing the whole calculations out of here. So in the year 2000, had we stuck to electricity, we would have saved more money than going into vapor absorption. But that's life, things keep changing, and these are some of the factors you've got to take into account when you design a system for the future. you're going to also be able to predict which way the prices are going to rise of these components. So Mr. Surendra Shah will tell you all these variables, and before I end up giving a speech on energy itself, I hand you over to Mr. Surendra Shah.
Thank you, Mr. Gopalna, Mr. Verma, and all the people who have stuck on till this late hour to listen to this speech. At the outset, let me tell you, there is another difference between pharma industry and other industries. Pharma industry has a group of most dedicated and most talented engineers and managers that I've ever met, and I've seen many industries. And it's been my honor and pleasure to work with many of you, and I hope to keep doing so together. And it is because of the open mind and the receptivity to new ideas from the pharma industry that we have been able to come up with energy saving solutions, which are now saving around almost 2 crores a year to its users. To start with, let me explain this question of how we plan new industries. Like Mr. Nair said, he took advice of a consultant, I suppose, and with all the calculations went in for a vapor absorption system. Similarly, let me tell you about some friend of mine, a neighbor of ours, in our small industrial estate. He wanted to come up with a garment manufacturing industry because there are a lot of garments being exported. So he decided to go for a good consultant. So he said, okay, let me go and look for one. He looked for a guy who had worked for a textile mill and retired at 70 years, and was supposed to be one of the best engineers that mill had ever had. Went down there. His advice was, I've been using for last 30 years nothing but a line shaft driven by one motor. So take one big motor, put a line shaft, put a lot of pulleys, lot of leather belts, and run your stitching machines with those belts. So I've got 30 years of experience to say that it works. It has been working for me, and I can guarantee it will work. Needless to say, the gentleman in question installed maybe about 60 Juki machines, and is doing quite well. The Juki machines are individual, electrically driven sewing machines. So this whole idea of line shaft and all that, which worked beautifully well, what he was saying was right, but it is not viable today. Now what will you say if I were to tell you that the pharma industry is also using line shafts in their air conditioning system? You're not convinced? What is a central chilling plant? It's a huge motor running a chilling machine. It's got a lot of pipes, a lot of pumps, and it's feeding little bit of cooling water to a lot of air handling units. The amount of complexity, amount of loss of energy is phenomenal, and it's unbelievable. It worked very well in the last 30 years ago. It was the right thing to do. There was plenty of energy. Energy was not a very costly thing. Plenty of space. Good engineers were available. Very cheap. It's not so now. The trend now should be more efficient, more reliable, individual units, and those that are highly energy efficient. Energy efficiency and performance should be the key words. So those of you who have central plants working should take an energy audit to see how much money you are losing, and then take those plants and give them to your competitors. That will save a lot of money to you and give you a big advantage. Starting with this idea that most of the pharma industry, major amount of air conditioning is used for low humidity. So I would like to spend another 3-4 minutes to explain to you what the concept of humidity is. So please start. As you see on the chart, the line A You consider that line A as a cylinder of water, and the black portion is the amount of water filled in it. In which case you can say that that cylinder is 60% full.